All right, first thing I want to do is say sorry. I apparently mishanded one of the pages out to you. So there's two double-sided instead of one. If you don't have this page 1 right here, it's available for download on my site. I put the whole thing up there. So go to my website and download it. This only applies in 2018. If I'm using this video next year, don't worry about it. We're going to explore angles of rotation and coterminal angles. To do that, we introduce something, will eventually be a unit circle as we go around, but we introduce a way of measuring angles in which, right, you have an initial side right here. So let's read it right here. In trigonometry, we express angles as angles of rotation. So the distance around. Rotation basically says we're turning this direction or this direction. All right? Angle of rotation, theta, right here. And I'm going to point out right here, this little symbol right here is called theta, right? Is formed by starting and ending positions of a ray that rotates around an endpoint. So if we make this always the initial side, right, theta is created by making a ray that may rotate to a point. So it may continue to rotate. The standard position is when the position of a ray or initial side is on the positive x-axis, this being the x, anything positive would be on this side, and has its endpoint at the origin. All right? So that means I'm over here and my endpoint is right here at 0, 0. All right? So my ray rotates. So in geometry, we're accustomed to working with angles having measures between 0 and 180. So that would be from here to here, right? In trigonometry, angles can measure greater than 180 and less than 0. We can even be greater than 360, right? We can pick almost any angle we want, although some of them end up in the same position. To see why, think in terms of revolutions or complete circular motions. Let theta be an angle of rotation in standard position. So 90 to here, right? 180, 270, 360 would get us all the way around a full rotation. All right. So when we rotate counterclockwise, we use positive, right, degrees, right? We rotate clockwise this way, although it seems a little counterintuitive. We use negative, all right? And there are things called coterminals. So we'll talk about coterminals. They share a side. So I'm going to show you two coterminals right here. Right here. All right. So if I went this direction, and I'll count it out about 257, so there's 90 degrees. If I keep rotating, like if I keep rotating 90, then I rotate 180, 257 would be about here. All right. Coterminal is this, an angle that shares the same terminal or end side. This ray that we're seeing right here, if it shares this side, it's coterminal. And notice if I go backwards 103, I get to the same spot. Please take note that these add up to 360 together. All right. So, number of rotations. You can have any number of rotations of an angle, so angles can be greater than 360. So one full rotation would be 360. Two would be 720, right? So below, we're going to show you 420, right? So 420 would be all the way around 360, right? 360. And then to get to 420, right, I need another 60 degrees. So it would be another 60 degrees. So 360 plus 60 would give me my 420 right there. All right. We'll finish up down here. All right. It says draw an angle of rotation to 310 degrees. In what quadrant is the coterminal inside? So if I want 310 degrees, look here, I'll do it right here. There's 90. There's 180, that's two 90s put together. There's 270, right? That's three 90s put together. And I won't make it all the way to 360, right? I'm only going to 310, so that's 270, 270, plus another 40-ish. So it's probably somewhere around here. This angle right here would be 310 degrees. And there it is, right? It says draw a positive coterminal. So if I'm going to draw a positive coterminal, that means I can't go the other direction. And there's only one here, the 310. So I have to go all the way around. So I'm going to go here. I'm going to go all the way around to 360. And then I'm going to come all the way back and add another 310 to that. Right? So that would be 310, that's where I want to go, plus I have to go all the way around again to get there. So I've gone all the way around 360 plus 310 for a total of 670 degrees. It says draw a negative coterminal, right? So negative goes this way from here to here, and that would be, I'll say it, negative 50 degrees, right? But to get to 310 the other direction, I'll take a full circle and subtract 310, and that tells me I'd have to go 50 degrees to the negative. I'll put the negative right there to get that same place, all right? Describe a general method of finding angles, all right? So here it is, for n equals, well, number of revolutions, all right? For the number of revolutions, we can take our angle, so whatever theta is, for instance, when we took 310, and we can add 360, or we can take theta and subtract 360. Look, 310 minus 360, all right, or 360 minus 310. Actually, I should have done that the other way to tell you the truth. Now I'm looking at it, 310 minus 360 gives me a negative 50 degrees. And there it is. We're done with the first page.